Today we're talking about process costing. It's the second of the two major cost accumulation systems. As I was discussing with the student prior to hitting the record button, it does tend to be a little bit more difficult than job order costing. I think it is a little bit more confusing, especially the way the author describes it. My hope is to walk you through the chapter and take you through the same 4 steps each and every time until we get in a rhythm for solving these problems. My hope today is to really hit the first 2 steps hard. Those 2 steps are going to deal with a concept called equivalent units. I'm going to try to explain that a little bit better than the author did. And then the last 2 steps, we're going to bring dollars into it. So that's where we're headed. Any questions before we get started? All right. Agenda. I use this to organize myself and then for you guys to use as a test review to go back and make sure that you can do all the things that we talked about. So today we just mentioned that we're talking about 2 major cost accumulation systems. We've covered job order costing. I've seen probably about 10 of you complete the homework on chapter 15. It looks pretty good. Today we're going to focus on the other cost accumulation system. It's called process costing. Sometimes you'll hear it referred to as continuous costing. I think that's even a better term because you're just cranking out, you're manufacturing something all day long. Tends to be used for pharmaceuticals, gasoline, paint, lots of chemical related type things where they're just processing all day long. Food processors use it. Down off the 405 freeway, we see an oil refinery that use it. And in actuality, many of companies use a hybrid of both. So we won't worry about hybrid costing systems. We'll leave that for the accounting majors. Right now, we're talking about our second major cost accumulation system. So the accounting challenges that you're going to see, not so much how the costs come in. It's more so how do we distribute all of these costs with inventory that's in various stages of production. So if Shell Oil down off the 405 freeway were to say 9/2 is our cutoff date, right? Shell Oil is not going to shut down because the accountants need to value something. They're going to keep cranking that gasoline and oil out all day. And our job as the accountants is to figure out what part of the costs are attributable to the stuff that's in process and what part of the costs are attributable to the gasoline that's already been produced. That's going to be our challenge. I'll show you that in a T account format shortly. Here's these 4 steps. These definitely need to get in your notes. I'm going to follow these 4 steps for the next 2 days. And I call it, well, the first one I call track the units. The first thing I want you to notice is that the first 2 steps are only units only. There are no dollars in the first 2 steps. So sometimes part of the challenge of process costing, there's so much information given. Some of it's going to be irrelevant. You'll see me cross it out as we read through it. But the first 2 steps, we want to just hone our eyes in on just the units. And then these last 2 steps, we will bring dollars into it. So we're going to demonstrate each one of these 4 steps. My hope is after class today, you should be able to do the entire chapter's worth of homework. Okay, the handout. First thing I tried to do is just to give you an overview of what exactly is process costing. Okay, it's a continuous manufacturing series of steps that go on all day long. It is usually referred to as push manufacturing. What does that mean? It means you're just pushing the stuff through the production line, trying to crank out as much as you need to make sales forecasts. That's much different from job order. Job order was customized. All the output looked different. It was pull manufacturing. It was pulled through the systems by the job orders or the customized series of steps that we were following. So here are some characteristics, I would call it, of process costing. It's repetitive production. The same thing goes on every time. I'm going to show you a little 5-minute video on a company that might use process costing. Homogeneous products. Okay, that means all the output looks the same. High production volume. They're just cranking out gasoline all day at Shell. That's what they do well. That's what they do best. And because all the gasoline looks the same, it's very low flexibility, right? The gasoline needs to have that same octane characteristics every single time. And because it's low product flexibility, that means the products don't change much. There's high standardization, okay, which is completely the opposite of job order costing, where there was no standardization. Every single thing was custom. So the major difference that you're going to see is the costs are not tracked by job anymore. We don't have job order cost cards anymore. They're going to be tracked by process, hence the name process costing. What does process mean? It means the various stages that a product goes through to become a finished good. And because some of us may have never been inside of a factory, I'm going to show you a very short, it's less than 5-minute video on how baseballs are made. When I was growing up, I wasn't allowed to watch too much television, but one of the things my parents used to let me watch was something called How It's Made. And so this is a short clip from How It's Made. And what I want you guys to be thinking about is the different processes that these baseballs go through. And what would happen if we walked in at midnight tonight into that baseball factory and said, stop, we need an accounting report? How would we be able to allocate those costs between the balls, the baseballs that are in the first stages of production where they have this raw core versus the baseballs that have several strings of twine wrapped around it versus the ones that are sitting over there completely finished? It is important that you have a visual cue of what these processes look like. So I'm going to watch this 5-minute video with you. For some reason, if you want to watch it again, you could either Google it or it's on my traditional website under the videos link. So less than 5 minutes, I want you to be thinking about the different processes. Okay, here we go.
When they make baseballs for the pros, they aren't just playing around. They build these balls precisely to league standards.
I think I accidentally stopped it.
And incredibly, those standards date back to 1872. Each ball is uniform in circumference and weight, so the game is an equal contest. Crowds will go wild for these professional baseballs, and at the heart of each one is something called the pill. The pill is smaller than a golf ball. It's about 10.5 centimeters in circumference. Inside the pill's rubber casing is a sphere of cork. They pour latex adhesive over hundreds of pills loaded into a drum. Rollers spin the drum to evenly coat the pills with the adhesive. This adhesive never dries out completely, and the pills remain sticky to the touch. Next, they loop 4-ply wool around the pill. This machine spins the pill to wind the yarn around it. This winding substantially fattens the pill. It's the first time a camera has ever been allowed to record this proprietary machine, so we can't show you all of it. They wind a second layer of wool around the pills. This yarn is 3-ply, and it thickens the ball a little more. For a third winding, they use another 3-ply yarn, but it's a bit lighter. The various layers of yarn are what gives the baseball resilience, so it springs back into shape despite being hit repeatedly. For the final winding, they use a much thinner polywool blend because its surface is smoother. This wound pill is called the center. They weigh it and measure its circumference, which should be 22.5 centimeters. They add adhesive to a spinning drum, then load the centers into it. As the centers tumble, they absorb the glue and the wound fibers adhere to each other. Centers air dry for 48 hours, but remain sticky. Using this hydraulic press, they punch out figure-8 shapes from leather, complete with holes around the periphery, allowing them to be stitched into baseball covers. But first, they stamp the date and lot number onto them. Then they wrap them in wet towels. The moisture will make the leather pliable enough to sew. Roll the water-based adhesive onto one side of the cutouts, which sticks to the moist leather. They press 2 cutouts to the center sticky surface. It's an exact fit. They clamp the leather-clad ball in a vise, and it's time to sew. Working with 2 needles, the sewer pulls thread through the ball's center and up through the holes in the leather pieces to cross-stitch them together. He rubs wax on the thread to stiffen it, because if it slackens, it's more likely to tangle. When it comes to cross-stitching, these workers are in a league of their own. They make quick work of the 108 stitches in each ball. There are 350 sewers in this factory, and they produce 8,000 to 10,000 balls per day. That's a lot of home runs. The final stitch goes through the center of the baseball and out the other side. The sewer then pulls the stitches into a V configuration to give the ball a consistent look and feel. The balls now roll into a press that smooths down the seams. Smoother balls are harder to grip, and they make pitching a bit tougher for the pros. Finally, a 3-headed stamper gives it the trademark, league logo, and the commissioner's signature. With drying cycles, it takes a week to make a professional baseball. It will be whacked and slammed out of the playing field. But that's life in the big leagues.
Okay, so somebody like this, let me get back here to what we were looking at. A company like this, I don't know how many processes you guys wrote down, but I probably wrote down 10 to make a baseball, 10 different processes. And at every point in making that baseball, the costs just keep building and building. They started with that pill, and then they wrapped the 4 different types of thread or twine around it. Every single one of those is a process. And at every single one of those points, the baseball incurs more and more costs, more and more labor. And so what happens, instead of recording this on some type of a job card, all this company's doing is cranking out baseballs all day long. They're going to have costs accumulating by these various departments, and the cost gets bigger and bigger and bigger, and then it's transferred out to the next process. And then it gets bigger and bigger and bigger, and it's transferred out to the next process. That's how process costing works. So we usually have more WIP accounts and more overhead accounts, and it can get a lot more complicated than even what you see in this chapter. So our goal in this chapter is for you to be able to accumulate the costs at least through one department and to see how those costs flow again from birth till death. At the most, maybe in day 2, we'll bring in a second WIP account, but for our purposes right now, we're looking at how do you process the cost of those baseballs that go through a major department. That's what we're after. And literally, I counted, I think, 10 different processes that these baseballs went through to become that pill to the final product. By the way, after watching those guys sew like that, and those ladies sew, that's why you guys are going to college. I can't imagine a repetitive factory job like that, doing the same thing each day, but that's what many laborers do. So we want to educate ourselves so that we can be the one that runs the factory. But that was amazing, seeing the 100 and some odd people in there sewing those balls. So I wanted you to have a picture in your head of what a process might look like. That was the purpose of that. Let's see. We're going to go through these 4 steps. The key to understanding, I think, the key to understanding process costing is this major concept that we're going to hit hard today called the equivalent units of production. The other thing I would tell you to do as you're visualizing what's going on, go with the process that you may be familiar with. And the example I always use is something like making cookies, right? If you were to name the steps that you went through making cookies, most of us would probably say, well, the first thing you need to do is you need to mix the ingredients. So there might be a mixing department. Let me get a new Word document up here so I can just jot down some notes. I thought I had one up here, but apparently it moved to my other screen. All right, so if we're going to make cookies, I'm just visualizing what I would do. You would have a mixing department, right? That's where all the batter, the eggs, the sugar, the butter goes. And then all those costs eventually would get transferred to the next department, which is the forming, I would say, where you have to actually form the cookies. That means you roll them into little balls. Maybe you put a little fork through them if you're making peanut butter cookies, but forming. And then they would go to baking. And eventually they'd probably be transferred to finished goods. So something as simple as making cookies, just in the very basics there, they'd have probably at least 3 WIP accounts. So what happens is all the costs come in, and we're still talking about the same type of costs. We're talking about materials, labor, and overhead. In that way, they are the same as job order costing and how the costs come in. The challenge is at any given point in time, there is a valuation that needs to be made about how much inventory is sitting in there ready to be sent to the next department and how much inventory is still unfinished when they shut the operations down. We know by definition that anything that's not done is still sitting in the WIP account. So I think the challenge of this chapter is not going to be in how the costs come in. It's going to be on valuing the inventory that is ready to be transferred out because it's 100% done, or the inventory that is sitting there unfinished. Maybe when you cut the ball factory down, all the balls are sitting in the 3rd spinning. Well, we have to allocate the cost to the balls that are done. Those have part of that cost. And the balls that are still sitting there in pill form or in this spun form waiting to be finished. So that's visually kind of what's going on. I wanted to hit hard this concept of equivalent units because that's the concept that's so important. And I don't think they did too good of a job explaining to you what the equivalent units of production is. So I'm going to attempt it this way. And I've had pretty good success making this comparison. Let's assume that you have 5 classes, right? And that each, you guys are college students, you're probably familiar with the term paper. Let's say you have 5 classes. Let's just write some down here. We all know you have an accounting class. Let's say that you're taking your econ class, you're taking a sociology class, you're taking a calculus class. I'd hate to be doing the homework for this person. And then just to make things interesting, you have a sex ed class. Okay. And each one requires a 3-page paper. To 100% finish all the products you're making on this research paper, if each one had a 3-page paper, you would have to do 15 pages worth of writing to finish up your term paper. Okay, so the equivalent units of production ask this question: how many units could you have finished if your effort was focused from start to finish? But here's what happens in a factory. Here's what happens in your term papers. You may decide that, man, the accounting class is the most boring one I have, and you write nothing. You don't do anything for that class. And econ's kind of interesting. So you do 1 page out of, remember, there's 3 pages that each one requires. And sociology kind of interests you. So you do 2 pages on that one. Calculus is still the class that gives you nightmares. I'm talking to myself. So you do nothing on that one. And sex ed really interests you. So you finish that one on the first day of class, 3 pages. Okay. Here's the equivalent units of production. You finished only one whole paper. This is the only one that is 100% complete. That's the only one that's going to get full costing in this manufacturing environment. So this is what I call a whole unit. It is 100% complete, and it's going to get 100% of the costs. But if you were talking about equivalent units is the number of papers you could have finished with the same effort that you put in. You could have finished a total of 2 equivalent units, right? So once again, you have one whole unit. You have one paper that's completed from start to finish. But if you would have focused your effort and you wrote those total of 6 pages, you had the equivalent of having 2 papers finished. That's my concept of equivalent units of production. So I'm going to get that definition in there one more time. The number of units that you could have completed with the same effort. The number of units that could be completed, that could have been completed with the same effort. The number of units that could have been completed with the same effort. And of course, I didn't leave myself enough room. You guys can fill it in. The number of units that could have been completed with the same effort. I think equivalent units is the crux of this chapter. I think when we're working through these exercises today, if we could keep this example in our mind, how many units could I have finished if my effort would have been focused from start to finish? I think that's going to be the crux of this chapter. I think that's going to be the light bulb that may not be on yet because we haven't started, but that should be flickering by the end of today's class. Okay, let me close out that Word document. I just want to go through a couple of theoretical things using a PowerPoint. And then, of course, I want to spend some time getting our hands dirty. So I think I've mentioned this in my handout, but I just, again, want to give you characteristics of process costing. Okay, I think we mentioned this earlier. Identical low-cost items, they tend to be lower cost items, and usually it's high volume. Mass production, okay, much of the time it's automated. Now, we saw in the baseball example that wasn't too automated. I'd be really interested in seeing what a Rawlings factory looks like today. You can't trace each unit. You can't trace it to a unit. Instead, we trace it by department. You're going to be seeing lots of WIP through departments. We said it was repetitive processes. You saw those sewers, they just sew all day long. That's what they do for 8 hours a day. And as that ball got bigger, as it went through from the pill to the adhesive, to the wool, to the final cover, it keeps increasing the costs. So the costs get transferred from one department to another department. That's how this is different. Job order costing that we did in chapter 15, the cost moved by jobs. You had a job card and it was easy to see when a job was finished, and when it was finished, it just went to finished goods. Process costing is continuous processing. That was the other name the author gave it. And so each process, the cost gets bigger and bigger and bigger. Our challenge is going to be on that cutoff date to decide how much of the cost is going to go to these finished products, that one whole term paper, and how much of the costs are going to go to the ending WIP. How much of the cost should be in an unfinished state, still have something left to go on it. That's going to be our challenge. And in the book, they show you kind of the layout of these different WIP accounts. So I just wanted to show you that. And we were talking about, actually, I had no idea this slide was in here when I ran across it. We were talking about balls. So does your book. Your book talks about tennis balls forming a rubber core and then eventually getting bigger and bigger. And this time they were doing tennis balls. You'll notice that there's several transfers between departments. The only difference that you would see is it's not going from WIP to finished goods. It's going from one WIP account to another WIP account. So you may have multiple WIP accounts as we work through this problem. And I think That's all I wanted to show you, except for this definition, because this is an important definition. The number of units that could have been finished if the effort given was the same. We just did a term paper example. So I think we're probably ready to jump in and try one of these. Reading the chapter is essential. If you haven't done that yet and you're waiting till the lecture, that's fine, but make sure you read the chapter. And then you should have watched the video from last night. All right, let's jump in and get our hands dirty. On the screen, you'll read that the first production department in a process manufacturing system reports the following unit data. We need to read carefully when we take a look at these problems, because many times there will be irrelevant data or things that we don't need based on the calculations that we're asked to perform. Again, I want to focus on the fact that there are 4 steps to process costing. The first 2 steps only involve units. The last 2 steps involve converting units to dollars. We're asked to complete the equivalent units of production for 3 different circumstances. So all we're interested in are units. I'm going to use a T account to help visualize what's going on. Remember, some data is not relevant to what we're doing, and some data we may have to calculate. So if I go back to getting ourselves in a rhythm and each and every problem create this T account, then we'll start to understand the various steps. So the problem starts out with 24,000 units sitting in beginning WIP. Those 24,000 units represent units that were started in a previous month but not finished. The next line, units started and completed, tells us that there were 15,000 units that not only got started but got completed. Okay, well, you'll notice that this little T account doesn't care about what was started and completed. What it cares about was units that were started during the month. And then what you're going to see shortly is that the first 2 line items here, beginning WIP and started, always have to equal the last 2 lines, the transferred out and the ending WIP. Another way of saying that is the goods come in to the department, shown here with the beginning and started, and all of those units wind up in one of 2 places. Either they are finished, in which case we would transfer them out to the next department, or they're not finished and they're hanging around in ending WIP. So the second line here is not relevant to what we're doing. I'm going to pass over it. The third line here says units completed and transferred out. That is relevant. When units are completed, they are transferred out, and they could be transferred out to finished goods, or they could be transferred out to another department. So I'm going to go ahead and put that 80,000 in. And then in addition to those 80,000 units being transferred out, there's also 16,000 units still hanging around in ending WIP. Okay, stop. Remember what we talked about last time, a few minutes ago. The sum of these 2 must equal the sum of these 2. So I'm going to use color to help you visualize what's going on. The sum of the yellow items must equal the sum of the, let me get some more color in here, orange items. Okay, that equality will exist each and every time. So if we saw 96,000 units either transferred out or remaining in ending WIP, that means the sum of these 2 must also equal 96,000. So although they didn't ask you explicitly in this question to compute that started figure, we're going to get ourselves in a rhythm each and every time by following the same steps. So I'm going to go ahead and calculate that. That would be the 96,000 in the orange boxes less the 24,000 units sitting in beginning WIP. So once again, the sum of the yellow must equal the sum of the orange. Why the units that came to us during a period of time have to be accounted for one way or the other, either as being finished, which means transferred out or to another department, or they're still hanging around here waiting to be finished. We're using something called the weighted average method. Your appendix talks about the FIFO method of costing. As this is a survey class, all we're interested in is the weighted average method. That's actually going to make our lives easier. So I'm going to read the directions again. It says compute this department's equivalent units of production. Okay, this is a key step in those 4 steps for direct materials. So on my screen, you'll notice that conversion costs are not mentioned. So on many problems, we'll be asked to complete the equivalent units for both materials and conversion costs. But in this case, the focus is just on direct materials. Okay, so we're going back here to this assumption that 80,000 units were transferred out and 16,000 units were still hanging around in ending WIP. They give us 3 different assumptions. A says all the direct materials are added to the product when the processing begins. Okay, what does that mean? Think of cookies being made. All the ingredients go into the cookies as soon as the beginning process, or the mixing process probably, is underway. So in weighted average costing, always 100% of the units will have received the direct material. So in all of these problems, the transferred out units, those 80,000 units, will have received 100% of the materials. Why? Because they're finished. They could not become finished unless they had all of the materials in them. So I'm going to take 100,000 times the 80,000 units, and all 80,000 units got material. It's the ending WIP that can be a little bit tricky. Letter A says since all the materials are added when the process begins, even though those 16,000 units are not finished yet, because the process has been started and all the materials go in when the processing starts, 100% of these units also would have received the materials. So all 16,000 units hanging around in that orange WIP box also got materials. So in this case, where the materials are added at the beginning, when we foot this, we'll find that 96,000 units received materials. Okay, remember what equivalent units of production is after. The number of units that we could have completed with respect to materials if our efforts would have been focused. So using that term paper example, although we started and completed 56,000 whole units, we could have completed 96,000 units if our efforts would have been focused from start to finish. Proceeding on with letter B, when we used weighted average costing, which is the only thing that you're responsible for in this chapter, we already mentioned the fact that 100% of the units transferred out would be assumed to have received materials and conversion costs. That means when we use weighted average, you want to totally ignore any percentages related to beginning WIP numbers. You'll notice that letters B and C have beginning WIP percentage completions. When we use the weighted average, those are totally irrelevant to what we're computing. So we'll ignore those. This problem focuses only on direct materials. So once again, all 80,000 of the units transferred out would have received materials. So I'm going to write that down, 100%, always using weighted average. But as we read letter B, it says that ending inventory is only 75% complete with respect to materials. So those 16,000 units that are hanging around down there are only 75% complete with respect to the materials. So I'm going to take those 16,000 units, multiply by 75%, and the result is 12,000 units. So the equivalent units of production for letter B's assumptions would be 92,000. I'll highlight that in green. Moving on to letter C, and let me move my T accounts over. Moving on to letter C, once again, beginning WIP percentages are completely ignored. What we want to focus on is how further or how far along did we get with respect to materials. Well, once again, all 80,000 units are considered 100% complete anytime that we use weighted average costing, and ending WIP was 30% complete. So in our last example, we'll be taking the 16,000 units that are hanging around in ending WIP and multiplying it by 30%, because 30% of the materials 30% of the ending WIP received the materials that they needed. Next month, those units will become the beginning WIP and they'll be completed in a subsequent month. So with the assumptions given in letter C, we have a total of 84,800 units. Take a moment to review that, and if any questions come up, make sure you get your questions answered. This will be our first problem where we actually go through all 4 steps. So to refresh your memory, we are breaking down process costing into 4 steps, which we will repetitively try to complete during all of our exercises and problems. Step 1 and 2 involve units only, so we're going to focus our data on just the units. And as a reminder, when we use the weighted average method, which is the only method that you're responsible for, these percentages related to the beginning WIP are irrelevant and we'll cross them out. So let's take a look at a T account to help us figure out steps 1 and 2. Step number 1 officially will be called track the units, but let's go ahead and take a look at this T account. I've carried over the 25,000 units that we started with in beginning WIP. I also carried over the 300,000 units that were started during the period, and I subtotaled those 2 items to give us 325,000 units. Those are the units that we need to account for. Those units can only go one of 2 places, either to the transferred out, shown here in green, or if they're not transferred out, they are uncompleted and left here in ending WIP. The author will go back and forth on which information he chooses to give us. Sometimes he'll make us calculate the missing components, so it's important that you understand the logic. In this case, he gives us both the transferred out units, let me type those in, 295,000, and the ending WIP has to be 30,000. Why? Because the yellow units to be accounted for have to match the disposition of the units either to finished goods or possibly to another department or an ending WIP. Let me officially show you what step 1 would look like by taking that T account side by side and tracking the units. So here we see the same T account with the items on step 1 filled in. So it's the exact same data. Here's the yellow side of the T account. Here's the green side of the T account. These two numbers always have to balance. So in your notes, the equality on step 1 is imperative before completing the next set of steps. Step 2, and probably the toughest step for most students to understand, is to calculate the equivalent units of production. We've already figured out that there were 295,000 units transferred out, and as you may remember, weighted average always assumes that those transferred out units got 100% of the materials and conversion. So there's a notation that the transferred out layer is always 100% completed. The ending WIP layer is what can cause people trouble. So looking up at the start of the problem, the ending WIP was 80% complete with respect to materials, but only 30% complete with respect to conversion costs. So let's go ahead and do the math by taking the 30,000 still hanging around in ending WIP times the 80% for materials. That equated to the equivalent of 24,000 units. And let's take that same 30,000 units times 30% for the materials. Adding those items up, we can see that the equivalent units of production for materials was 319,000, and the equivalent units for the conversion costs were 304,000. Take a moment to look those items over. They are key in completing the rest of the problem. Once again, the equivalent units of production is the number of units they could have completed had they focused their efforts from start to finish. This is the first time that we'll bring dollars into the mix. Step 3 is to calculate the cost for one equivalent unit. You'll notice that the author tells us that the units came to us partially completed from the previous month and brought along with it 44,800 of material costs, 15,300 of conversion costs. So this is the cost that came along with the units uncompleted from the previous month. In addition to that, this month they incurred additional costs of 1,231,200 in materials and 896,700 in conversion costs. Let me add those up, double check our math. It's always a good idea to foot and cross. We've accounted for all the costs coming in. Notice that we match the author's total here. You can also look up and check the T account up above. And our final step, if that's the cost of all the goods coming in, to calculate the cost for one unit, we need to divide by the number of units. And that would come from step 2, the step that we just completed. So I'm going to go grab the 319,000 equivalent units for materials, and let me go grab the equivalent units of production for the conversion costs. Let me allow the computer to divide those two amounts. That's the cost on the top and the units on the bottom, and we'll get an amount of $4 for direct materials. And I'll do the same math for the conversion costs. Let me carry that over. And when you add up those two line items, you'll see that one whole unit cost $7. Those costs will be used to finish off our calculation in step number 4. So maybe pause the video, take a look at the first 3 steps, and if you have any questions, make sure you get those questions answered. Last step, step 4, we're going to dollarize step 2. What that means is in step 2, we computed the equivalent units of production for both of our layers, both transferred out and ending WIP. In step 3, we computed the cost per equivalent unit for each one of those line items. So the last step is going to take the units from step 2 times the cost from step 3. Let me write down the steps for you. Our first layer is transferred out. All 295,000 units, as shown in step 2, was costed out at $4 a unit. That was for materials. And all 295,000 units in the transferred out layer also got conversion costs of $3 per unit. Right now I want you to focus on the logic, and we'll do the calculation in a minute. The last layer here, ending WIP, again, the hard part's been done. We know that there's 24,000 of equivalent units sitting in ending WIP for materials. So let's take that 24,000 units multiplied out by the $4 per unit. And then in the conversion, we have those 9,000 equivalent units costed at $3 per unit. Take a moment and do the math, and let's come back and check our calculations. So here is our final answers for step number 4. Take a look at the final answers and take a moment to check your work. Prove to yourself that the costs coming in equals the costs that have been distributed. So in the T account at the beginning of this problem, we showed that the total costs coming in were $2,188,000. I'm going to change these other yellow boxes to be green. And based on step number 4, we've shown that those costs were distributed mostly to the transferred out units in the amount of $2,065,000, as well as the ending WIP layer of $123,000. Again, the sum of the costs in have to equal the sum of the costs distributed. The costs coming in for the month have to match where the costs were distributed. So take a moment to check your math, and if you can go back and try that problem one more time without any assistance, then the light has gone on and you will have a great understanding of process costing. The light may just be flickering right now. We have several more exercises to work our way through. The more you practice and the more you get your hands dirty, the better off you're going to be. Let's get ready to try another one. This problem will have us calculating the first 2 steps on this worksheet, and we'll calculate the second 2 steps on the next worksheet. First thing I want to remind you about, since we're using weighted average, cross off any percentages related to beginning WIP. You'll see that I have completed the first step for us. Steps 1 and 2 are related to units only. So looking at the information the author has provided, we started out the WIP account with 60,000 units. We added in the 322,000 units started. We subtotaled the WIP account, and that's how many units came in. Now it's up to us to determine how those units wound up, where they got distributed. The author tells us that 300,000 units were transferred out, and that means that the ending WIP, those units still in an incomplete state, remain. In this case, 82,000. So step 1, using that information for the T account, tracks the units. The yellow line items are here. The green line items are here, Remember, we always have to ensure that that equality is in existence. Let's move on to step 2. Step 2 can often be the toughest step for students to understand. Our goal is to take these 2 green layers and convert them into equivalent units of production. Remember the definition of equivalent units. Transferred out, the 300,000 units are assumed to be 100% complete, so carry those units over. The ending WIP, however, is incomplete. The author tells us at the top of the problem that the ending WIP was 80% finished with respect to materials, but the conversion costs were only 30% complete with respect to direct labor and overhead. So we're going to take the 82,000 multiplied by 80% on this one, and we'll take the 82,000 times 30% on this one. Do the multiplication. When you add them up, we have our equivalent units, which will help drive the rest of the problem. Steps 3 and 4 are actually requested on the next tab, but for ease of understanding, I've just snipped or copied the costs over, and we'll complete the problem on this tab. Step 3 brings dollars into play for the first time. So we know the units that came in, and now we're going to place dollars to the units. So here's the information for the beginning inventory. You'll notice that the author tells us how much came into us in terms of costs from the previous month. We had 118,472 in materials and 48,594 in terms of conversion costs that came to us uncompleted from the previous month. This month, there were also another layer of costs that came in, 850,368 for materials, the cost of materials this month, and for conversion, 649,296. I'm going to add them up. Here is the total costs in that we need to account for to prevent any transposition errors from happening. You may want to add these across. Let me see if I can move this out of the way to get that number in, just to double check ourselves. When I add these 2 across, we do come up with the same number the author had. So to get from the dollars down to the cost per unit, we need to divide by the equivalent units of production. That came out of step 2. So I'm going to go grab those units. Here they are right here. I'm going to drag them over here. Here's the equivalent units with respect to materials. Here's the equivalent units with respect to conversion costs. I'm going to come back and divide the total cost divided by the units, and I will do that for both materials and conversions, and I don't think we need that many decimal places, so let me carry that down to dollars and cents, which would be 2 decimal places, and now we have the cost per equivalent unit. On to our last step. The goal here is to dollarize step 2. How are we going to do that? We're going to take the units that we computed right here and multiply them by the cost that we computed in step 3. So again, all 300,000 units were transferred out would have completed or would have carried with them 100% of the costs. So 300,000 times $2.65 would be what I place here for direct materials, and for conversion it would be the 300,000 times $2.15. Get that line item first. Then ending WIP will be the one that many people struggle with. We'll take these units derived in step 2 and multiply those units by the costs derived in step 3. You'll hear me use the word dollarize. Take a moment to do that step and we'll come back and look at the answers. Here we see the completed answer, the transferred out units fully costed at $1,440,000, and that ending WIP layer, when we added them up, we came up with $226,730,000. I would strongly encourage you to add up those two numbers, and then to double check your answer, you may want to consider making one final WIP-T account with dollars. The yellow cells represents the cost coming in as given by the author, and the green numbers represents where the costs were distributed to based on our 4 steps. The costs coming in have to match the various costs distributed. You'll see that based on our summation right here, the costs in do match the costs distributed, and you've just completed a successful process costing problems. Let's go on and do one more for additional practice. Our last problem is there as just one more instance to give you some practice. The hope is at this point, after working through 3 or 4 exercises, that light is starting to flicker. So what I would encourage you to do is what we've been doing all along today. Start with the visual WIP-T account. Now it looks like he may have given us less information on this one. So I'm going to go through this first step with you. You'll notice that I've created a WIP-T account for units and a WIP-T account for dollars. I think that helps visually. Again, we're going to totally ignore any percentages complete for the beginning WIP, as they are not relevant to what we're doing. In this problem, I've put in the 2,000 for beginning WIP. Completed and transferred out would go over here on the credit side, 23,000, and the ending WIP was given to us at 7,000. So the author tried to give us a little bit of a curveball. He didn't tell us how much the started units are, but that's okay because our units have to match. So the next step I want you to do is think about the left hand side of the T account equaling the sum of these two. The sum of these two are 30,000 units. That means the sum of these two must also be 30,000 units. So just in case he sneaks in a multiple choice question which asks you how many units were started, you'll know how to complete that. So we will take that WIP visual cue and go ahead and recreate step number 1 for track the units. Go ahead and try that and I'll be back to show you the answer. So here's what step number 1 would look like, where we tracked the units. That was based on our WIP-T account. Step 2, which is again usually the most confusing for students, is to look at our 2 layers and calculate the equivalent units of production. Weighted average is always 100% completed, so we simply brought down that $23,000. Ending WIP still isn't finished by its very definition. The author told us that the materials were 100% completed, but he told us that the conversion costs were only 40% complete. So we took the 7,000 units here in the ending WIP layer and we multiplied by 100% and then 40% respectively, and we would have added those two up. Step 3 is the first time that dollars come into the mix. So I snipped the information from up above so I wouldn't have to keep changing screens. And the goal here on step number 3 is to calculate the cost per equivalent unit. Another way of saying that is how much does one completed unit cost. So we took our beginning WIP for both direct materials and conversion straight from the author. That information's right here. And then we added in this month's cost. Materials were $375,000 and conversion was 341,000. Add the costs up. It would also be wise, as I've demonstrated before, to cross-foot them to make sure that you don't make any transposition mistakes. Here you can see that the total costs in match the author. Since our goal was to get the cost for 1 unit, we would divide by the equivalent units that we derived here in step 2. And when we do that, we find out that 1 unit costs $14 for materials and $15.40 for conversion. 1 whole unit, in case the author throws that at you on a multiple choice question, would be $29.40. The last step, step number 4, is to allocate the cost or dollarize the amounts. The way we're going to do that is by taking these 2 layers that we derived in step 2 multiplied by the costs that we derived in step 3. You may hear me refer to it as dollarize. As this is our last problem for this lecture day, go ahead and try to do step 4 yourself, and I'll be back with the answer. Okay, take a look at the final step 4, where we took our 2 layers derived in step number 2 and multiplied them by the cost per equivalent unit derived in step 3. Take a look at the calculations. Our goal was to determine where the cost went. We know that there were 2 layers left to cost, those units that were completed in this department and transferred out, and those units which were still left hanging around in ending WIP. To finalize this problem, I would encourage you to take a look at a WIP-T account that has dollars in it. The yellow items are the dollars that the author provided to us. We refer to those as the costs in. And the green items were the costs that we computed based on these 4 steps. Foot the T account and make sure that the yellow costs in equals the sum of the green cost distributed. That's process costing. It's not an easy chapter. My one piece of advice is you need to practice, practice, practice until that proverbial light comes on. This is Professor Johnson signing out.